Welcome back to Data Programming 1. Today we have our second lecture on pandas. This is the first of a 4-topic sequence, special topics, as part of the data science section of this course. We're going to be talking about pandas, we'll be talking about the web and web scraping, we'll be looking at databases, and wrapping up with plotting. All right, as we get started, please go to the web page. There is a worksheet there. We're going to begin with some of the problems on the worksheet. There's also in the code directory the template for this lecture and some CSV files that we'll be using. At this point, there is no template. I'm going to be creating it as we go through, as I do the lecture, and then I'll just go ahead and delete all of my work. So what you guys see during the lecture will be a little different than the template that is the final product. So go ahead, download those files, put them in a directory, get Jupyter Notebook open so you can follow along. And a quick review as we get started. So remember, Pandas is a really powerful tool for working with tabular data, tables of data, like you'd see in a CSV file or a spreadsheet like Excel. Pandas introduces 2 brand new data types that give us a lot of flexibility in how we deal with this type of data. The first is the series. It's a hybrid between a list and a dictionary. It's going to have both indexes, which work like dictionary keys, and it's going to have integer positions, which work like list indexes. It's going to give us the power to do element-wise operations, like you'd see with vector math. It's also going to be able to use that really powerful boolean series to select certain pieces of the data. All right, we're going to do a quick review of that at the beginning. Well, then I want to do a little bit more to review data alignment and just clear some things up. And then we'll dive into the new data frame, which is Panda's second data structure that they introduce, used to represent tables of data. You can think of it as the columns of the table are actual Pandas series. So we'll get to that in about 10 minutes. All right, so here we're looking at the worksheet that's available from our code directory. The first 3 questions all work with series review. I'm going to go ahead and do number 3. This is the one that reviews Boolean series, which I find to be a very powerful technique and well worth investing some time to learn. Then on page 2, we have questions about data frames. So after today's lecture, definitely take some time. You should go through and you should do all of the problems in this worksheet, not just the one I'm going to do for the class demo. All right, I'm going to go ahead and copy these over into the template so that you guys have them and you can take notes in the Jupyter Notebook template as we go through the lecture. All right, so this series of questions is just asking us what is going to be the result of this operation. So in line 1 of this cell right here, I'm declaring a series. It's got the numbers generated from a list, -1, 1, 200, 191, and 4. Then I'm just going to ask a series of questions about this and produce what the answer is going to be. And I want you guys to think about this and make a prediction. I'm not even going to run these. I'm going to leave that up to you guys. And I'm just going to put here in comments what this is going to produce. In fact, the way I want you to use this is pause the video and try this one out. Make a prediction as to what you think is going to happen, and then come back, and here's the answer. Okay, so what's going to happen is we're going to create a series that's got -1, 1, 200, 191, and 4 in it. It's got those values. And then we're going to ask this question. This is a relational operator. It's going to say, is v less than 0? This is going to happen element-wise. So it's going to go through and take a look at this one right here and return the value true. Then it's going to go ahead and take a look at this one. 1 is not less than 0, so that's going to be false. 200 is greater than 0, so that one will also be false. 191 less than 0, also false. And finally 4 less than 0, false. Okay, so it's a relational operator that's going to produce a Boolean result. So here we're going to have, because we're creating the series from a list, it's going to use those indices to come up with the indexes, and they'll be the same values as the integer positions. So there we go. So we're going to have those keys, or not keys, there'd be keys in a dictionary, indexes over here on the left. And we'll also have dtype, and this should be bool. I'm going to leave that off for the rest of these most likely. All right, there we go. That's number 1. This next question is basically got 2 steps to it. I'm going to go through and I'm going to multiply v times v. That's a much higher precedence than the equals operator. And then I'm going to see if any of those numbers that we generate are equal to 1. So let me just walk through this in steps. So first up is -1 times -1. That's going to equal 1. then 1 times 1 is equal to 1. I'm not going to type it all out every time. 200 times 200 is 40,000. Check this out. 191 times 191 is, let me run that cell. That number, so a big number, 36,481. And then 4 times 4, I got this one, 16. Okay, now that's the first part right here. So now that I've generated a new series with those numbers, I'm going to go through element-wise and decide if they're equal to 1. So this first one right there is equal to 1. So that'll be true. Second one is exactly 1. True. 40,000 is not equal to 1. So false. Again, that 36,000 is not equal to 1. Neither is 16. Okay, then this will be at position 0, or index 0, index 1, index 2, index 3, index 4. Make it look good. D-type, bool. Number 3. Go ahead, pause the video again, do this one, just write the answer out right here, and then come back to watch the solution. Okay, in this problem, I'm going to start with the inside of all of the brackets, and that's just this piece right here. This is going to generate a boolean series by asking if these are greater than 100. And then we're using, so inside the brackets, we're using this to access the series and use that boolean selection to make a decision about what to keep. And this is going to produce a new series with just a subset of the elements. Okay, so here's how this is going to work. First up is v greater than 100. Is minus 1 greater than 100? No. That one will be false. Is 1 greater than 100? No. False. 200 greater than 100? Yes. True. 191 also greater than 100. And 4? No. So that'll be false. All right, the next thing we're going to do is go ahead and use this as a selection mechanism to select just pieces of the V series. So let me go ahead. At position 0, V has the value minus 1. At position 1, V has 1. Make it look good. At position 2, the value is 200. Formatting. I'm trying to make this look good for you guys. All right, at 3, we've got 191. And at position 4, we have the number 4. Okay, so now I'm going to go through and I'm just going to delete all of the rows that have false in them because they will not be retained in the final answer. So those two have false. We're not going to keep them. These two will also be false. And in this case, I don't need the trues anymore. That's not part of the answer. This is my answer right here. I've got, go ahead and put in index and value. And D-type is going to be int, likely int 64. All right, cool. Hope that made sense. Important thing to remember is the index is actually retained. It's like the key from a dictionary. It's retained when we do this selection. All right, next up, go ahead, pause the video, make a prediction about what you think this one's going to look like, and then come back for the answer, which I'm doing right now. Okay, so first up, we're going to look at the insidemost of all the brackets and start with this. All right, this is an expression, and we've got the left-hand side of the equals over here. We'll evaluate that one. Then we'll see if it's equal to 0. And then finally, we'll use that. That'll give us a Boolean series as a mechanism to select pieces from the series. Okay, so first up, the v mod 2. All right, in that case, this is our sort of odd-even test. So basically, it produces the remainder. So minus 1 divided by 2 has a remainder of 1. Okay, and then 1, well, divided by 2 has a remainder of 1. And again, okay, I'm going to stop writing that. So 200 is an even number. When we divide by 2, the remainder is going to be 0. 191, an odd number, will have a remainder of 1. And 4 will have a remainder of 0. All right, let me shorten these up again. Okay, so that's what we're looking at for those values after we do just this part of it. All right, next up, I need to make a decision about whether these are equal to 0. So in this case, that's going to be false, false, 0 is equal to 0, true, false, and true. All right, cool. So then from here, I'm going to use those true and false values generated by that expression to select pieces from V. Okay, and now here I've got indexes 0, 1, 2, 3, 4. And the values here are -1, 1, 200, 191, and 4. Okay, and then again, I'm just going to delete the rows that have false in them. So those will not be retained. Whoops, I almost missed. That'll not be retained. And these are the two even numbers from this list, 204. Those are the rows that'll be retained. And this was just me doing some work. So I'm going to go ahead and delete those. Make this line up a little better so it looks good. D-type, you guys guessed it, int 64. All right, next up, pause the video, go try this one out on your own, and then come back for the answer in 3, 2, 1, go. Okay, so we're going to start with the innermost expression here. This one actually has two innermost expressions that I need to look at. So I'm going to evaluate v greater than 0 and v less than 100. These are both going to give us boolean values, true and false, and then I'm going to use the AND operator. And if they're both true, we retain it. If either of them are false or both are false, we will exclude that line when we do this boolean selection here. Okay, so first up, I'm going to do the v greater than 0 and just put that in a column right here. So -1 greater than 0, false. 1 greater than 0, true. 200, true. Basically all the positive numbers. So 191 and 4. Here, just I'm just putting my numbers in so I remember what they are. 200, 191. I'm going to need them when I generate the final answer anyway. So there we go. And that was v greater than 0. So next up, I need to do v less than 100. All right. So is -1 less than 100? Yes, it is. What about 1? Yes, it is. 200? No, it's not. False. 191? No. False. And 4? Yes, it is. Okay, so these are the numbers. Oh, hold on. So the next thing I need to do is use this ampersand. This is the Pandas and. Remember, they weren't able to just use the word and. They couldn't overwrite that one. So they chose a different operator and overwrote that and made this one have the and functionality. We got all these extra parentheses in here because this has a really high precedence, and we need to make sure that these operations happen first. So quick review of what's going on there. All right. In order for and this entire expression to be true, both of these guys have to be true. So false and true is actually false. True and true. Whoops. Oh dear. Typo. False. False. And true. And this is the both. Let me just write it like this. Just do the and right there. Okay. And now this is the final answer for like which pieces am I going to use for selection. I'm going to retain the rows that have true. Let me go ahead and put in my indices right now before I go ahead and start deleting stuff. And then I messed up all of my formatting. Put that back. Okay, there we go. So that looks really good to me. So now I'm going to go through and just do, not perfect yet. All right, delete the rows that have false in them. So we will not keep that one. We will not keep those two. And there it is, final answer. This should be the numbers between 0 and 100, exclusive. All right, cool. And now this is all the work I did to get there. I'm going to go ahead and just delete that so that I have my final answer over here on the right. No longer need that. And this will have D-type int 64 if everything went well. All right, so next up, I just want to go over on one example with data alignment and talk about one of the little gotchas that may arise and how to deal with that. All right, so I'm just going to create some series. X is equal to series need parentheses. I'm going to create this from a dictionary. A is, let's go ahead and make that 10. We've got key B is 100. I use the word key there because I'm creating a dictionary inside of the series command. I'll go ahead and create S1 equals, I'm just going to copy and paste this because I want it to have the same keys. I'm just going to give it different numbers. Let's go with 2 and 3. There we go. S2 will also make that a series. And what I'm going to do here is I'm going to switch this. B and A. So the alignment is different. Let's see, B was 3 and A was 2. There it is. Okay. Whoops, I accidentally deleted that. All right, so next up, I'm going to go ahead and run this. And oh, right. Okay, so escape, push A to add a cell above. I never imported pandas. So let's go ahead and do that now. So there we go. We'll get that one. And then I'm also going to need, oh, let's do it this way, a shortcut. I don't want to have to type the whole thing. And I don't want to have to type PD at all if I'm just creating a series or a data frame. Those are so common. So I'm going to use the other kind of import to import both, grab the series, and then for the second part of the lecture, data frame. All right, so we'll run that. We'll spell it right next time. Oh, good Lord. At least they're next to each other on the keyboard. Okay, there we go. So then just to verify, I've got X here. That's my series. I've got indexes A and B because I created from a dictionary, and S2. All right, so make this a little bigger. There we go. Now they all fit on the screen. Looking good. Now, when I talk about data alignment, what I'm going to be doing is some sort of operation like X times S1. That's we would totally expect this to work. Everything is lined up already. We've got A in integer position 0. It's got a 10, A in integer position 0 here. So we expect that this is going to create a series with, what, 20 and 300. Okay, great, 20 and 300. When I do an arithmetic operation with S2, with things that are not lined up, so in this case, S2 has B in integer position 0. It's still going to work. It's going to prioritize the index, and it's going to line up the A right there and that A right there. So I should get the exact same answer here. And it does. That works great. Okay. The problem I run into is when we start using relational operators. So this is an update. This used to work. I could have said X less than S1. S1. Man, twice in a row I've mistyped S1. Okay. Yeah, so this will work as long as everything is already aligned for me. So here I've got X with A in position 0, A within position 0. So if we run this, it works great. If I do this without aligning the data first, and then I run this cell, it's going to give me an error. And here's the key part of this: can only compare identically labeled series objects. This is new. The first thing they have to do if they're going to compare series with different indexes is sort both lists so that they can line them up. And that sorting takes time. And so they've removed that in order to improve performance. The idea being that if you're going to be doing a lot of less than operations or a lot of relational operations, particularly seeing if something's equal, extracting pieces of data from a data frame, they want you to sort the data ahead of time, store it, and only do that part once. Then you can make your comparison. I'm just going to comment this out and copy and paste this error message so that we can remind ourselves what's going on here. All right, we're on that cell to get rid of all the errors. So essentially what we want to do is something like X is less than S2, and then we'll sort by index. And now this will work because I've gone ahead and taken care of this sorting, so that now all of the indices are aligned for us. All right, Pandas has built in a number of functions so that I can perform on series. So this is a method, a series method. And so I'm using less than. So the function method for less than. So this is another way to do it without bothering to align the data. I can go ahead and just call the less than method. This is going to work. It's going to produce the answer. And this takes care of that alignment for me when I use this function. All right, there's, what do we got? 6 really common abbreviations. So let me just go ahead and I'm going to put them all in right here. So we got less than, greater than, less than or equal, greater than or equal, not equal, and equal. I'm going to pause the video and put in comments for these. Okay, so there's all of the abbreviations. Here's a demonstration of how they're used. It's actually printing out this last one right here. They're not equal to each other. All right, let me go ahead and make a little comment right here. So this is the series methods for relational operators. These are just built-in things in the series to go ahead and perform those operations. This is, we'll make it markdown. We'll run that cell. There we go. That's how you add comments. Let me add another one. Demo that for real. Okay, so here, this was my, I'm going to push escape. I'm going to add a cell above with A. I'm going to write my code here. This is markdown. The £1 means this is like header 1. And so what I'm going to do here is this is my data alignment section. So this code will be there in the template. Let's see. Now I'm going to push M to switch this to markdown. Alternatively, I can go up here in the code and make it markdown like that. Then when I run this cell, it's going to go ahead and put that in header mode. If I go ahead and edit this, turn this back into code, just a heads up, if I add more hashtags, that's going to change it from header 1 to header 2 to header 3. So it's going to change the size. Put that back in markdown by pushing M and run that cell. So now it's tinier. All right, so the next section of the lecture is going to be about data frames. I'm going to move into this second data type that Pandas introduces. All right, so to demonstrate this, I'm going to be creating data frames a bunch of different ways. So let me just do the first one here. I'm going to create it from series. Let me go ahead and copy and paste this from my notes. Let me see if I've got it typed correctly. All right, so here I'm creating a list, turning that into a series. Another list, so this is just going to represent some players and their scores, or maybe some students. Let's just call this name. Some students and their scores, players and their scores, something like that. When I run this cell, let's make sure this worked. I'm not printing anything yet. So we'll do column 1. We'll spell it right. Column 1. There we go. There's all the names. Column 2. That worked also. Now to create a data frame, keyword data, or command data frame, it's a function. So, and then I'm going to be creating this from a dictionary of lists. So the dictionary is going to require that I give them keys. These are going to turn into the column headers. So we'll have name and data, column 1, and then score, column 2. I don't need that extra comma, but it's just fine. There we go. So like I said, the keys from this dictionary, and there's no reason I can't spread this out and make it look good using more white space, has some extra rows. I kind of prefer that. I think it looks pretty good. Makes it easy to read what we're doing. So anyway, like I said, the key from my dictionary used to create this gives me the column name. And here's the data in that column, Alice, Bob, Cindy, Dan. And same deal with score. That's going to become the header for this table, the column label. And the data from column 2 is stored right here. Okay, when I'm making this using this technique, using a dictionary of lists, it doesn't actually know what to name these the rows. So it's just going with the indexes created by creating the series from a list. So here's the idea. I created it from a list. And so that's where those integer or the indexes come from. All right, so next up, we've actually got 4 different ways that we can go ahead and create data frames. Let me put in some notes here. I just wrote data frame from dictionary of lists, but I think if they all appear on the screen at the same time, we can kind of see a better pattern. Let me grab that right now. Okay, here we go. These are the possibilities. I can use any combination of dictionaries and lists. So dictionary of lists, a list of lists, a dictionary of dictionaries, or a list of dictionaries. And then later on in the end of the lecture, I'm going to do a CSV file example, but I'm not going to demonstrate that here with these combinations. Okay, so next up, I'm going to add a cell below and go ahead and demonstrate this. I'm just going to be copying some code from up here, and we'll go ahead and update this. Because right here, I actually have a list. Let me just go ahead and grab that list and replace the series with that list. Same thing for column 2. I'm going to be creating very similar looking data tables using all of these techniques. So this is a dictionary of lists. Go ahead and run that, make sure I didn't make any mistakes. And this should look identical to the one from the dictionary of series. Second technique, I can also use, let's see, a B for below, add a new cell, a list of lists. So in this case, this is creating a dictionary. I'm going to get rid of that, put the bracket in, and get rid of this dictionary closing bracket. And now lists don't have keys, so I'm going to remove those and create a very similar looking data frame here. Okay, so in this case, is that really how I want to do this? I think, no, this isn't how I want to do it. I want to look very similar. Okay, so here's version 1 where I've just used the list from above. Let me go ahead and add a new cell, and I'm going to change this a little bit. So instead of using this list of lists, go ahead and delete that. I'm going to use, grab that, comma that, 4, so that my table looks the same as before. Okay, in this case we'll have a list that has Alice and her score, what she got, 4 points, and then we'll have Bob, who got 5 points, Cindy, oops, I missed, with 6 points, and Dan with 7 points. All right. When I run this, I get a, it looks much closer to what I had up here. So in this case, when I'm using a list of lists, it's kind of like reading a CSV file. I have all of the data from each row in its own list. All right, so in this case, Alice, 4 points becomes Alice and 4 points. Note here that we no longer have the column names, so it's just going to go ahead and put in the integer position as the index for those columns, so 0 and 1. I'll talk about how to change those in a moment when I'm done demonstrating all of these techniques for creating data frames. Then we'll talk about upgrading them. All right, and again, these indexes here come from the integer position because I'm still using lists. Okay, next up, a dictionary of dictionaries. So to start with, let me find the one that contains a dictionary of lists. And we'll just go ahead and add a cell below, paste that right here. And now instead of this list of names, I need a dictionary. And dictionaries have keys. So let's go ahead and put in a key for all of their names. So we'll have A, B, these are just going to be the row names, C and D. And I'm going to do the same thing for this list. I'm going to upgrade this to a dictionary, doing very similar. So I need keys for all of my values. Let's go ahead and copy and paste these in the right spots. I'm going to run this. We've now created another data frame. It's got the same data in it. I'm back to having column headers, and now I've got row labels. I could put anything I wanted in there. A, B, C, D seemed like a good choice for this example. All right, and then finally, a list of dictionaries. So I'm going to copy that. We'll go ahead and add a cell below, paste the code in, and now I'm creating a list, so I'm going to switch those brackets right there. It automatically put in that for me. Thank you. And then I just need to create a list of dictionaries, so I'm just going to delete the keys because this is no longer a dictionary. So list of dictionaries. I'm going to redo this. Oh, I copied the wrong one. Timeout, timeout, timeout. Okay, I'm going to leave this in here. I guess I don't have an example where I can copy and paste. Let me go ahead and just type this in. I'm going to need one dictionary per row so that it doesn't come out sideways like that. Okay, so in this case, I'm going to have a dictionary for each row, and the label here is going to be the column header. So this is going to be name, and Alice is going to get a score oops, I accidentally hit enter, score, colon, quote, and she had 4 points. That's going to be the end of this first dictionary. Something like that. Let me just go ahead and see what this looks like without the rest of the data. Yep, so name, Alice, score 4. I'm going to go ahead and put in the other 4 dictionaries for the other players. Oh, this actually will go really fast. Copy, paste, copy, paste, copy, paste, score 4, 5, 6. Whoops. Oops. There we go. Okay, so now we've created a data frame from a list of dictionaries. When we do that, we no longer have these row labels. Instead, we've given the data and told it exactly which column to put all of the data in. All right, next up, let's talk about labeling the rows and columns. And markdown, run that. The best example for this is going to be this list here, created from this data frame created from a list of lists, because the labels were automatically generated from the just integer sequence. Okay, so I'm going to paste that one here. We'll go ahead and run this cell just to see what's going on. And now data frames take an additional keyword index. So this first piece is the list. There's a keyword parameter or keyword argument index, and this is just going to take a list where I can label the rows. So in this case, we'll go with A, B, C, and D. Okay, that's the first part. If we run this cell, I've now replaced the 1, 2, 3, or 0, 1, 2, 3 with the letters A, B, C, D. There's another keyword argument that I can add, columns. Let me just have these over so they're lined up. And this is also going to take a list, and this is going to be the column headers. So here we have name and score. There we go, perfect. Name and score. All right, so I want to start the data lookup section next with just a quick review of how series work. So let me see, let me grab a good example. I don't think I have a good example. I'm just going to copy the names here and go back down. So here what I'm doing. I'm going to create a Pandas series using a dictionary. I've got the 4 names here. So these are going to be my keys. And we'll give the players scores. All right, when we run this, we get a series with the keys, I'm sorry, not keys, the index and the values as their score. So to look things up, quick review, we can use, I need to store this in a variable. Let's call it scores. And we've got several options. So we could use the location and give it, square brackets. Give it a key, like we can look up Bob's score, like that. Scores, what did I name it? Oh, I never ran this cell again. There we go. There we go. Okay, and just get the 5 like that. We can also do integer position and go ahead and grab, let's go ahead and print this out so we can see what's going on too. There we go. There's the list or series. We can also use the integer position and grab whoever's at position 1, run that, or even the last position with -1 and get their score. All right, and the third way that we could access data from the series was by not using location or allocation and just letting Pandas figure it out. So we could ask for Cindy's score, and it's going to go through the list. It's going to first go through all of the indexes and see if that choice is one of the indexes. Then it's going to go through all of the integer positions if it's not available. So if we want to grab Cindy, another way to do that is scores. I just need the integer 2, and that's going to go ahead and get her score as well. She's in 0, 1, 2, position 2 of that series. All right, for data frames, we're going to have the same 3 options: location, integer position location, and just straight up let it figure out what to do. So I'm going to go ahead and grab a data frame. We'll go ahead and use this one so that we can print it out. It's got nice looking, I'm going to call this DF so that it's short, easy to type. We'll go ahead, there we go, and then we'll just print it out so we can see it. All right, so yeah, this is the list of lists where I've labeled the columns and rows. Okay, so I've got three choices. Again, I've got my data frame dot location, put something there, data frame dot iLocation, and just df without any qualifier, just the bracket access. Okay, now the writers of Pandas had really a bunch of choices as to how these are going to produce data. And it turns out the location, they've decided this is going to extract a row. So I need a row index right here as my parameter or argument. Let me just put that as a comment instead. Give it a row index. So in this case, my row indexes are A, B, C, or D. So let's go ahead and grab row A. I'm going to put this in its own, I'm going to do these in their own cell. Let me move these down a little bit. We'll run this one. This is going to produce a series. So this should look like a series where I've got A, or Alice in the first position, score in the second position. These are the indexes of that series. It's giving me D type, data type as object because I'm mixing strings and integers. It's smart enough. It'll figure out what's going on. But because I've got multiple types of data, it's going to default to the generic object. Okay, and then let's see. I also had, next one was df, iLocation. This is also going to return a row. So I need to give it a row integer position. So in this case, let's go ahead and grab row 2. That should be Cindy's row. And again, it's producing a series. So we've got the index Cindy, index score gives us a 6, and again, object. Okay, and the last one was just using the square bracket to access the data. This one is going to require a column index. So in this case, let's go with, let's see, let's just remind myself, I capitalized it, its name. So we'll go ahead and put that column name right there, run this, and this is going to return a column of data. So again, the authors of Pandas had a choice. How do we make this work? And they decided that the one that requires the least amount of typing should be the one that I want to use the most. And when you're using, think about how you guys use spreadsheets. I use mine to keep budgets. I use it for gradebook. The thing that I do most often is take a column of data and like add up how much money I've spent or find the average score on an exam, those sorts of things. So the most common application for at least how I use things is to grab an entire column and then perform some sort of operation on it. So I could grab score, I think I made it singular, and then I can call any one of these series methods like max, that's a series method, and that's going to return the max score is 7. Dan got that. I can find the mean or the average. Average is 5.5. Sum is another choice. Yep, add up all the scores. All right, so those first couple methods where I only gave it one argument gave us an entire row or an entire column back. Because we're now dealing with tables, which are two-dimensional data structures, if I want to get a specific value out or I want to change a value, I need to give it both indexes. So just a quick reminder, here's my data frame. Suppose I wanted to get Bob's score out of here. I need to give it 2 items. So data frame, use the, let's do the location version. So we'll get row B and we'll get the score. Run that, it's going to return that 5 right there. I can use this same method to update score. Let's go ahead and give Dan in row D 10 more points. And then we'll print out DF. There we go. So now Dan has 17 points. Doing really well. Maybe did the extra credit assignment. We can do the same thing with the iLocation too. So df.iLocation. Just give it 2 things. Like how about the row, how about the last row, and column 0? That's going to be, so last row, column 0 is going to be Dan. Indeed, produce Dan. All right, next up, slicing. Just like we can slice lists, we can also slice data frames. So let me go ahead, grab a new cell, new header. So as you can imagine, when we slice a list, we're getting a subset from the middle of a list. Same thing with a series. When we slice a data table, we're getting a section. It's a 2D rectangular section of that data frame. So let me just quick reminder. Here's what the data frame is. Let's grab the middle two rows. All right, and so this is the way it's going to work. I'll have data frame dot allocation, give it the square brackets for data access, and then I need a row, indices, and column indices. Okay, so that's how this is going to work. So let's grab, let's see here. Let's do rows 1 to 2. This is inclusive. Inclusive, exclusive. So I need 1 to 3. And then let's grab all columns. So that's just the colon. And that's going to produce Bob and Cindy. It's grabbing the middle of the table. All right, a little heads up, kind of a gotcha. I can do the same thing with location, and I can grab between rows B and row C. We'll grab, row indices and column indices. We'll grab all the columns. But this one, when I use location and give it indices, is inclusive and inclusive. This is the only place I know of when we're slicing lists, series and data frames, where we switch from being inclusive on the first term and exclusive on the second one. But it does happen to work like this, and I'm not sure why the authors of Pandas chose to do it this way, because it is different. And something else we can do, we can use a slice to modify a whole bunch of data all at the same time. So I'm going to go ahead and give everyone 100 more points. So they'll be very happy. So in this case, we're going to use, let's do iLocation to grab all of the rows. We'll give everybody. And scores are in position 1. We'll just do plus equals on this. Give everybody 100 points. And so this will be all rows, score column. And then I need to print out the data frame again after I run that. Oh, and I ran it twice, because I ran it and then I put the print in there. So now everyone has an extra 200 points because I did that twice. Here, let me go back and reintroduce df. Where did I assign it? Yep, right here. I'll run this cell again. Now everyone's back to their 4, 5, 6, 7. And then we'll go ahead, we'll give Dan 10 more points. So he's got 17. And then we'll run this cell exactly once this time. There we go. Now it's exactly what I intended. I needed to start over. So this is a little different. When I slice a Python list, it's going to create an entirely new list. That's not going to give me the power to go ahead and change things using this kind of arithmetic. Data frames work differently. It's not creating a brand new data frame object. It's just referencing a piece of the larger data frame. And so I can go ahead and use operators to change it. So a little different from what we expect from Python in that way also. And one other final way that I'm going to introduce slicing of data frames is using a list of indices. So here, we'll grab the data frame. We'll use, oops, I missed. I keep hitting enter when I don't intend to. I'm going to give it a list for rows, and we'll just grab all the columns. So we'll grab row Bob. Oh, wait, he's in row B. And we'll grab row D. And when we run this, location. I do that a lot. Okay, because I keep talking about positions. That's the language I use when I talk about where something is in a list, but the command is location. Can't get that one straight in my head. All right, so yeah, this is a very powerful technique for slicing into a data structure, like a data frame. I can just give it a list of which rows I want, or which columns I want, and create a subset of that data. Doesn't have to be that rectangular block. I can choose exactly which rows I want. Okay, next up, boolean indexing. Okay, so a quick reminder, if I have a series like S, I think I still have a series named S, not defined. What did I name? S1? There we go. I've got a series S1. Actually, all of my examples from the beginning of this lecture, those problems from the worksheet, we're working with Boolean indexing on series. So we can give a series, a boolean series, and that'll pull out here, get all values that line up with true in the series. And let's see, true is capitalized in Python. There we go. And I'm just going to leave this as a comment. We can do very similar things. A quick reminder, if I use square brackets right here and just give it, a variable, this is going to get all rows, columns, don't misspeak, Mike, that line up with index X. Okay, little comment. And I'm going to do something very similar here. D of a Boolean series is actually going to do row selection, get all rows that line up with true. So I can give this a series filled with true and false values, and this is just going to create a subset of the table of the data frame with just the rows that have true in them. Okay, let me go ahead and do an example. So there's my data frame. Let's go ahead and give this a Boolean series. So that's series. And I'm going to create my series from a list of true, false values. So let's grab first row, false, true, false. Just stick some things in there. Oops, made a little mistake here. I'm going to create my Boolean series so that it has the same row indices as we have up here. That way I can do the alignment. So I'm going to upgrade this to a dictionary version. Right, like this, and then I need to give it keys. So we have row A, row B, row C, and row D. All right. Unexpected end of wait. What? Time out. Oops, I've lost the last bracket. So data access with Boolean requires those square brackets. I just deleted the last one by mistake. There we go. Okay, finally. Horrible disasters, typos, but I think showing you guys the error message and that I make mistakes is probably valuable too, so you can figure out what went wrong if you make the same mistake. Okay, so let me actually print out what this series looks like. So I'm creating the series right there. And so now I can see that I've got true, false lined up with indexes A, B, C, D. So Pandas is going to go and say, okay, what's it? Row A, do I want to keep this row or not? True, keep it. It's going to look at index B, false, dump row row B, don't need it, and so on. So like I was saying, this is a really powerful technique. If I want to do create this series automatically to decide something based on, like, here, let's do this. Get all rows with score greater than or equal to 106. So we'll include Cindy and Dan in this example. All right, so here's how I'm going to do this. I'm going to go ahead and just extract the score column, and that's going to be data frame, and then I want the score column. Let me just check and see that that gets me what I want. It's capitalized. Okay, there we go. I've extracted all the scores. And then what I can do is I can just, let me go ahead and use a new cell here. I can say greater than or equal to 106. That's going to go through and create this false, false, true, true, the Boolean series that I need. I'm going to go ahead and store this in a variable. I'll just call this B, short for Boolean. And then I can use this to access the data frame and just grab those rows. I forget to run the cell. Okay, there we go. For players that have scores greater than 106. Okay, so that was just a quick example of how to do this. Next up, I want to go ahead and do something more complicated, something more real, something we might actually see in a project or real life example. So I'm going to go ahead and download the movie CSV from the code directory. One second, let me show you what I've got here. All right, so in the code directory, I've got these files. This is the one I'm referring to, the IMDb movie database. You may have seen these somewhere else in the past. And then I've also got, here's the worksheet where those questions were. This is for some of the questions that we'll deal with later on. main is my notes. I keep my lecture notes, things I'm going to use for like preparing this presentation in Jupyter Notebook. And this is the current version of the file I'm working on. So let me switch back. As you can see, I've named this lecture 29. There were a bunch of comments in my last YouTube video about what happened to the so I named the last one lecture 28, and I skipped 26 and 25. So those were for the exam days. This is actually the 29th day of the course. And I didn't, create a video for the exams. I just kept numbering sequentially. And so after the exam, the first exam, I've been off by exactly one number from what Mina's doing and from what we did previous years. And it's just really bothering me that all of my numbers don't line up. So when we had the second exam, I was then off by 2 numbers. So I'm just going to update this. We're going to just keep going from lecture, actually numbering from which lecture in the course it is so that everything lines up and my lectures have the same numbers as Mina's do. Creating a data frame from a CSV file is very, very simple. So very, very simple. All I need to do is go ahead and call Pandas read CSV, and that'll go ahead and take a path as the argument. Make this a comment. And the name of the file is IMDb. It's in this same directory. And all I needed to do was type in the first 2 characters, IM, and then it automatically filled in the rest when I push tab. So I can tab complete that. Let me go ahead and run this, and I can see that I've got 998 rows of movie data with 9 columns. It's going to print out the first 4 and first 5 and the last 5. I can just see what's going on here. All right, to start exploring this data a little bit, I'm going to go ahead and save this in a variable. We'll run that cell again, and then we can print it out. All right, check this out. We've done a couple of weird things here. It's gone ahead and read the index values from the file. So here, let me just show you what's going on there. In the movie data, here's the CSV version. I've got all of the rows labeled with an index. I don't know that I really want that because Pandas is going to take care of that automatically for me. Let's go ahead and take a look at this. And when I read it in, it went ahead and added all of these indexes. So I've got it in there now twice based on the fact that it's generated from a list of lists. It's just reading in a list of lists. And when we did that, it's gone ahead and added these extra indexes based on the integer position of the list of lists. Okay, it's smart enough to know that this is a header row. It's grabbed that. All right, so let me go ahead and show you guys how to fix this. Here, let me demonstrate where this problem comes from, and check this out. So one of the other things I can do is I can call the command to-csv, and then I can give it the name of the data frame. Hold on. Data frame to-csv, the name of the file I want to save it as the argument. Let's call this. We'll just call it a.text. That should work. I'm gonna go ahead and run this cell. And now when I go back over to this directory, I can see I've got a.text. And this one now has 2 indexes. It saved it again. Let's go ahead and just have some fun here. I'm going to go ahead and read it again. Go ahead and read a.text. And I'm just going to run this cell a bunch of times. I'm just going to push Control-Enter. Oops, I made a mistake. Let me fix that. It's actually, here's the typo, and it's data frame equals Pandas read CSV. So if I just go ahead and run this cell 1, 2, 3, 4, you can actually see this incrementing over here. And now let's go take a look at a.text. There it is. We've now added a whole bunch of extra indices. So this is undesirable, clearly. I want to fix this. I don't want this to happen. So let's see here. Let's go back to the code. All right. I'm going to put a little label right there. Weird index gotcha. All right. I don't want to run this cell again. Actually, I really don't care. It's creating a.text. But what I really want to do is use this part right here. The the original file, IMDb movie database. Okay, so now let's go ahead and fix this problem. I want to get rid of the index column, and we'll just retain the rest of this, and then we'll just write out that much. So to do that, I need a slice. So I can say data frame is equal to data frame, and then we'll grab a slice. I want all the rows except, I want all the rows. And I want all of the columns except the first one. So that's going to be from column 1 to the end. Let's just see what this looks like now. Make sure I didn't make a mistake. I forgot the location. There we go. Okay. Let's print this out and just verify that I now have removed that index column. Okay, perfect. Now, when I go ahead and save this, let me just copy my code, the 2CSV. We'll go ahead, we'll put this back in A just for demonstration purposes. I don't want to actually overwrite the data. I want you guys to be able to go through this example with the same indexing problem. So we'll just write this to A, but I can give this the keyword variable, I believe it's called index equals false. Let me see if this works. Oops. False. Okay, yeah, that worked. So now I can go back, let's read a.text again and just verify that those all the index values are gone. Yep, okay, so there's no blank column here. None of these rows begin with a 0, a 1, 2. So we've successfully removed that extra indexing. All right, so just a heads up that weird gotcha from reading and writing CSVs. All right, let me head back over to my code. All right, and this is how you fix it. Just the 2CSV takes a keyword parameter, keyword argument index, and we just want to set that to false. Then it won't write out the indexes from the data frame. All right, there's some really valuable tools for starting to explore these larger data sets. The first one I want to talk about is head. Head is just going to go ahead and grab the first 5 rows of the data. So I don't need to, it's making a slice for me. I can also give head and a number and just get the first 2 rows or the first however many rows I want. I could grab 10, whoops, or 190 and print those out. I'm going to leave this as a small number so when we scroll through the data or the Jupyter Notebook, it's not taking up hundreds of lines. So this just kind of gives me an idea of what's going on with my data. I can also use, oops, what did I want tail. Tail is the last couple rows of the data. So this will be the last 5 rows of my data. And again, this will also take a number argument. So I could say grab the last 3 rows. And just a way to peek and see what the data looks like. All right, the next thing I want to point out is that when Pandas reads in a CSV, I can, let's go ahead, grab column year. Just, oops, is it capitalized? Capitalized. Capitalized year. It's gone ahead and recognized that, hey, all of these things are numbers and converted them to integers for me. So when you read a CSV in regular Python, everything is a string. And we needed to do an extra step to convert all of those back to integers. And I would say 99% of the time, if I'm reading a CSV that got numbers in it, I really do want those to be integers or floating point numbers. Like, check it out, the ratings here are all floating point numbers, revenue, floating point numbers. The one situation I've run into in the past where I didn't want that is student ID numbers, because when you put in like a 10-digit ID number, Python or Pandas will decide that I really want that to be displayed in scientific notation. And ID numbers in scientific notation just don't look the way I want them to. So a little extra work to convert those back to strings, but not a big deal. All right, at this point we can start to see the value of all of the ability to extract a column and perform some math on it, a function, without having to write a loop to go through. Like, for example, at the beginning of the course, if we had a data table like this and we wanted to figure out the average rating, we would have gone through, looped through all the pieces of data, added all those numbers together, and then divided by the number of things in the list. So, but Pandas makes this really easy. I'm just going to go ahead and grab the rating row. I'll just peek at that. There we go. Got just the ratings. Let me just call mean on that. And that's going to go ahead and return the average rating. If we want to find the maximum runtime, the longest movie in the list. I believe I called it runtime.max. The longest movie is 191 minutes. So a lot of those things that we learned early in the semester when we studied loops, those early projects are made very simple. Just one line of code to do a lot of things with data frames. All right, now I want to go through and just do a more complicated example, something to really demonstrate the power of Pandas and using data frames. So I'm going to go ahead and do something that would have been a very challenging problem during the movie project. So as my example, I'm going to find the highest rated movie that had an above average runtime. So first we would have needed to compute the average runtime. Then we would have gone through and selected all of those movies. Then we would have gone through and found the highest rating. And then we'd have gone through one more time to compile a list of all movies that had exactly equal to that rating. All right, something like that. There's lots of ways to approach that problem, but that 4-step process would have taken like maybe 100 lines of code if we broke it down into steps so it was easy to read. Here, I'm going to do it. I'm going to break it down into lots of steps, and then I'll just show you how to composite those steps. I think it's very valuable to be able to make your code as readable as possible. So the first thing I want to do is find the average runtime. So to do that, very simple. Data frame, we grab the runtime column, and then I'm going to call mean on it. We'll run that. What did I do wrong? Dot mean. Okay. Find out the average runtime of the movies is 113 minutes. Okay, perfect. Now what I want to know is all of the movies that have a greater than average runtime. So let's go ahead and create a boolean series of the true false values so we can use that to select which movies have above average runtime. Okay, to do that, all we need to do is grab all the runtimes. There we go, and find out which ones are greater than this number right here. And I've got some options. I could store this number in a variable and then just use that number. So we could say average runtime is equal to that, and then print out average runtime. I really prefer this method. Let me go ahead and run this, and forgot to run this cell. Yeah, run this one. Run this one. There we go. And now we've got a bunch of true and false values. Let's go ahead and take a look at the first 5 and just make sure that this makes sense. So runtime 121, that's bigger than 113. I should get a true. 124 bigger than 113. 117 bigger. 108 less than. 123 greater. Okay, so it looks like this is working. I'm just going to comment this out so that it's not taking up lots of space. Okay, now I've created a boolean series here. I'm going to go ahead and just store this as B. Go ahead and run that cell so it stashes it. Go ahead and print it out. I'll just print out some of it. There we go, the first 5 values. Next up, now that I've got this boolean series, I can use this to extract all of the long movies, the ones greater than the average runtime, from the data frame. So data frame of B is all I need to do to grab that. So let's just take a look. Movie 1, 0, 1, 2, we should skip 3. Looks like it's working. So I'm going to just go ahead and stash this in long movies because they have above average runtime. And then we'll go ahead, we'll just leave something printed out. And we'll just use head again to shorten up. We'll just get 3 movies to remind myself that I'm including. Let's do 4 or 5. Let's do 4. That way I can see I've skipped 1. That works. Okay, so next up I've got all the long movies. To do this, maybe in just one line, I want to demonstrate this compositing idea. I could have long movies equals, and now I had a boolean series here. My boolean series was this stuff right here. I can go ahead and actually just put this in my selection process right there. And I also used average runtime right here. I stashed that in a variable. There's no reason that I can't just go ahead and copy and paste the code that gave me average runtime and then run this. I should get the same thing again. grab the first 5, print those out, and we see that we've skipped a movie 3 and movie 5 just like before. All right, personally, I find this kind of code to be challenging to read. I'm actually pretty good at this, so it's not that bad. If you guys, when you're doing the next project, the one using Pandas, write code like this and it's not working, please go ahead, break this down into lots of little steps. If you come to office hours and you've got a composited statement and it's not working, I'm going to make you delete it and go through it step by step. All right, so good practice. When I did this, I wrote one line, I printed it out. One line, printed it out. One line, printed it out. Even though I've got all the things in one line here, it's possible to do that. Don't. All right, I'm not actually done with the problem yet. I was looking for the highest rated movie that's long. So from now on, I'm just going to be working with my long movies list. So long movies, spell it correctly. What I want to do next is find the highest rated movie from this list. So I'm going to go ahead and grab the rating column. And there we go. Just call max on it. This should tell me that the longest movie, or above average, has the highest rated movie has a 9.0 from this subset of my total list of movies. Okay, great. That's perfect. Let's go ahead and stash this in a variable. Highest rating equals that. And print it out. All right. And then from here, all I need to do is find which movies had that rating, and we'll create a subset data frame that's only got those movies in it. So to do that, when I'm selecting things, if I'm selecting a subset of the rows, I need a boolean series. So create a boolean series to select the movies with rating equal to highest rating. I'm going to go ahead and put the extra equal so it doesn't look like, so it looks like code. All right, to do that, I've got long movies. I have the rating column. And I just want to know which ones are equal to highest rating. Do that. Man, I'm having trouble typing today. Long moves. All right, there we go. Looks like we got a lot of falses here, and that's true. Very few movies will equal the highest rating. So that kind of makes sense to me. I'm going to go ahead and stash this in a variable, and we'll just print out a couple of them. All right. And then I'm going to use this Boolean series that I just created to extract the answer from long movies. Spell it right this time. We'll grab only the movies that have exactly equal the longest movie. Good Lord, I cannot type today. Worth. All right, there we go. So what we find is that the highest rated long movie is actually, where did my title go? Found the problem. So when I was going through talking about removing that index and the weird errors we were getting, I ran this line multiple times where I'd selected all but the first column to remove that index. And when I did that, I lost the title column. Remove the index, then remove the title, because I ran this more than once. Okay, so let's get this fixed. I'm going to go get a fresh copy of the movie database. I'm just going to add a cell below this one. Instead of a.text, I really want this one. All right, we'll run that cell. We'll run that cell. Yeah, all of these other columns were just fine. So long movies. Yep, titles are back now. Okay, perfect. I'm just going to keep running the cells to redo all of that work. There we go. Okay, title is there. And again, I didn't remove that index this time through. I just loaded a fresh copy. All right, so highest rated movie with an above average runtime, The Dark Knight. That was a great movie. I've watched that a bunch of times now with my son. He really enjoys superheroes. All right. Oh, okay, so last topic. This wraps up this problem. The last topic is just getting a bunch of composite stats about our data. And there's a very simple function, describe, that I can call on a data frame. And this is going to just return a data frame where it's taken all of the numerical columns. In this case, we have index, year, runtime, and rating. So index, obviously that's worthless. Year, runtime, rating, and revenue. Revenue must have some things like millions, or because it's not giving me like an average revenue. Probably have some like string issues there. Okay. But anyway, once we have this, we can see that like the average year that the movies are from in the data set, 2012. Average runtime, again, 113. If I want to extract some data from this, I can go ahead and just store this in a variable. We'll run that again. So we've got stats. Go ahead and print it out. And then this is a data frame. So I can just grab stats. I can index into this. I need, for example, a column. Wait, row first, then a column. So mean, runtime. Man, I did it again. I need the dot location. There we go. And now I can get the mean runtime. So the things we've got here, count, mean or the average, standard deviation, the minimum, the maximum, and these are the quartiles. If you're a stats person, you'll find that useful or meaningful. That's going to do it for today. Have a great day, everybody, and I will see you back on Wednesday.